What's going on, everybody? Welcome back to 5 Minutes on Crypto. In my previous video, I've introduced you to cryptographic hash functions. If you haven't done so, go ahead and check out that video. Like all my videos, it's less than 5 minutes long, so you won't lose much time. In this video, we'll talk about the use of hash functions in cryptocurrencies, and specifically in Bitcoin. There are two major purposes that hash functions serve. The first one is reaching consensus. Bitcoin is a currency. Like any other currency, it is used for transactions. In contrast to traditional currencies, there is no centralized institution keeping track of the transaction history, but instead, it is governed by numerous people around the world. The entire transaction history is composed of little blocks that accumulate over time. That's why it's called blockchain. Each of these blocks contains a number of transactions. Let's say the first block in our picture contains the transactions from an hour ago, the second one from 50 minutes ago, and so on. All of these transactions were already approved. Now the question is, who gets to approve the next block of still pending transactions? That is, the ones that happened in the last 10 minutes. Remember that Bitcoin is decentralized, so there's no financial institution approving these transactions. This is where the so-called miners come into play. These are not people who work in mines underground, but rather people who are using their computers to compete in solving a puzzle. The winner gets to approve the new block of transactions. So how does it work? Each of these miners has a copy of the blockchain on his computer. The miners select out of a pool of pending transactions, each miner may select a different set of transactions, and then try to solve a mathematical problem. What the miners do is they basically link the new unverified block with their set of selected transactions to the rest of the blockchain and then put it into a hash function. The output hash is some arbitrary sequence of 64 characters. The challenge for these miners is now to obtain a hash with a certain number of leading zeros, let's say 6 zeros. They can achieve this by slightly altering one field in the unverified block of the blockchain called nonce. As you know, changing the tiniest bit of the input to the hash function changes the output entirely, so the miners test out different values for the nonce field by trial and error. This goes on until the first miner finds a nonce value that produces the desired output pattern. This miner gets a reward in Bitcoin and gets to publish the blockchain with the new block. All the other miners can now check that he indeed solved the puzzle and that the blockchain is consistent with the one that they had stored on their computer. If all that is the case, they accept the new block and update their copy of the blockchain. So that means they reached consensus. Of course, all of this happens automatically, so miners don't actually sit in front of their computers and they don't manually approve everything. Instead, they have powerful computing resources sitting somewhere in, for example, Russia or Iceland. The second purpose that hash functions serve in cryptocurrencies is preserving integrity. Let's consider Bitcoin again. As previously mentioned, there is no centralized institution governing the Bitcoin transaction history, but instead numerous miners around the globe, and anyone can take a look at the transaction history, even you and me. Let's take a look at a small excerpt from this transaction history. Alice sends Bob 1 Bitcoin. Alice sends Peter 5 Bitcoins. Peter sends Susan 2 Bitcoins, and so on. Everybody can see these transactions. Note that the format here is simplified. In reality, there aren't any names, but more complex structures. What happens if someone tampers with this history? What if I, for instance, change one of the entries to my advantage? According to the new history, I now own 5 Bitcoins. If I am a miner and publish this transaction history now, it would take the other miners quite a while to notice the mistake, because everybody would have to double-check millions of transactions. Of course, there's a more efficient approach to detect tampering. Remember that miners already computed the hash of the blockchain. If I tampered with one of the transactions now, the hash would change substantially and all the other miners in the network would be alarmed without the need of having to go through all the transactions again. This is why the blockchain is referred to as an immutable, distributed ledger. Let's get to the summary. Hash functions play an important role in cryptocurrencies. First, reaching consensus over how new blocks are added to the blockchain. In Bitcoin, there are so-called miners who compete against each other over who gets to approve the next block of transactions. To do that, they have to find a hash that has a certain number of leading zeros. Second, preserving integrity. Hashes are used to encode the current state of the blockchain. If someone tampers with it, the hash changes entirely and everybody is alarmed. So hash functions make the blockchain an immutable ledger. There are even more use cases, for instance digital signatures. These will be covered in another video. Stay tuned and see you in my next video.